Yeah, hello, good morning. First of all, thank you for watching this video. My name is Vishnuvardan Ganesan and I am doing projects in miniature car autonomous by acting its autopilot mode. So here I am going to explain step by step. First, let me explain about the hardware setup and the software I have used, then the software installations and the challenges faced, and the machine learning, the e-pouch, and how I trained the model, and how I collected the data, and how I implement that data into the Raspberry Pi. So also I'm using PT software to control Raspberry Pi and the host PC. And yeah, that's the setup and I'm going to tell you. So first let me explain about the hardware setup. Here I have a donkey car, some Raspberry Pi microcontrollers, and the Pi camera is connected to the Raspberry controller. The HDMI cable is connected in the net interface so that we can access the Raspberry Pi controllers, softwares, and the folders and the codes and everything. So here we have a charger for the battery, down in servo motor, and some controllers to control the car steering angles, actuators to control the throttles. And here in host PC I have a softwares like Donkey Car and some other softwares to control via the Raspberry Pi. So yeah, let's finish. So let me explain about the software installation. And here in Raspberry Pi I installed the Python 3.0. Let me explain about the software installation process and here in Raspberry Pi controller as well as in my host PC. So first I will explain you about the Raspberry Pi controller software installation. So here I installed Python 3.7 series and the Donkey Car version 2.5.8 and some TensorFlow version 1.14.0. And also I created a my new car directory in the Donkey Car, and here in my new car directory where I collected data is stored in tab. I'll show you the number of images stored in tab, and also when I trained the model, the file saved in the models folder here in Raspberry Pi, and this is the configuration.py, so we can edit and change the PWM values for steering as well as throttles and some other codes, and here manage.py, so we can run the command by using python manage.py drive to collect the data, and some other the Donkey Car software is here. And yeah, that's it about the Raspberry controller. Here in host PC I also done the same process. Let me explain. Here I created the my new car directory from the Donkey Car. Also I created the Donkey Car installation herein. Also Anaconda prompt shell. Let me show you Anaconda prompt shell here, and I'm going to create some environment through this. I also installed the TensorFlow installations and some Python 3.7 series same. Also I'm using same versions in both Raspberry Pi and the host PC. Also this is one of the challenges I faced before. I installed the different version for both in PC and in Raspberry Pi and faced some issues around it while collecting data and implement that data in models folder. So that's why I learned from the challenges. Then I installed same versions both in PC and Raspberry Pi controller. And so this is the software installation I have done. So let me show you the PuTTY software that's controlled in host PC. This is the IP address I found, 979.3.25. And 76.3.25, and it will ask the host name Pi and the password Raspberry, and it will go to the Pi Raspberry Pi directory. Then here I will I'm going to activate the Donkey Car environment. So after that, my new car, and here I'm going to manage.py drive to drive the car and to collect the data. and it gives the URL address HTTP and the IP address .887, so that if you put this into our URL, we can run the vehicle and collect the data from that through the pipe camera. And yeah, and the collected data is saved here in my new car directory tab. A number of images as well as the steering values and the throttle values saved here in tab. So after I collected the data, I used WinSCP tool for transfer that tab folder into my host PC to train the model. So here this 10.76.3.25, the username as well. So this side I have the terminal in Raspberry Pi, and this side I have host PC. So I'm going to transfer my tab folder into here. Here in users. So I transferred by using this WinSCP tool. Once I transferred, let's show you the pictures. So that's the pictures I've taken from the Pi camera during the data collection. So following these lanes, and now I'm going to train that model through Anaconda shell prompt. That's the environment I'm using. So cd new car, that's the directory saved in models. And so I'm going to train the model by using python manage.py train. So models, my models name.h5, which will save in models folder located in my new car directory. And you can see it's training by using the TensorFlow machine learning. And the validation loss is going to improve by each and every e-pouch. It's aiming 100, but it will stop once it will get the lesser losses in throttle and angle validation losses. So here we got the lesser validation loss 0.0075 and angle out loss and the throttle out loss. We achieved it at 37 out of 100. So this is the minimum validation loss we achieved. So that's why it stopped early. So the train model is saved here in models folder. It's located in the my new car directory. It's named as my model name.h5. And I'm going to do the same process by using the WinACP tool. I transfer this my model name.h5 from here host PC models folder to the Raspberry Pi models folder, so that we can run the vehicle by autopilot by analyze these model codes which we train by using the different images we got it from the both lanes. So here I will show you the inside the models in the Pi camera. If we go to my new car directory, and here in models we have my model name.h5, and yeah, now I'm going to run the vehicle by using that model. So now we can use the PuTTY software to control the Raspberry Pi. We have the host PC. So this is the command which I'm going to use. Python manage.py drive model home pi folder in the my new car directory models my model name.h5. So I'm going to put it in PuTTY software, and it will analyze the directory and folder. At last, the same process which we got it from the data collection, the URL http and .8887 like this. So we can access this URL. So now we can see the web interface here. So here what I'm going to do is, this is the user mode. So here we can run the vehicle. So this is the local pilot D. By selected this local pilot D, the vehicle can run by its own by analyze the file which we entered, which we located in the model's name. So let me show you the vehicles. Yeah, this is the driving environment, those two lanes and the stopping signs and the pedestrian walking signs and some obstacles in the middle of the road. So this is same as like the road have just two lanes. So now the vehicle is going to analyze those two lanes which I have trained before, then going by in between the two lanes.